Hello, my name is Mirwa Al-Salami, and I am here to demonstrate the work for assignment 1 for Comp381. First, we have this function over here, and it basically prepares the datasets locally so we can load it. The output is just a confirmation of successfully downloading the two files. Next cell, it defines the function that loads our datasets into a table. There's no output yet because we're just defining the function. The next one, it loads the rows, and here the data are loaded correctly. Next function shows the data type and non-null counts. This confirms columns types and where value might be missing. This one over here is category counts for ocean proximity. This shows how many rows per location category, and the most common one is this one. This function shows the summary statistics for the numeric columns, like the housing median age, total rooms, total bedrooms, populations, and all of this. Next function here, it basically draws histogram for each numeric column to visualize their distributions. So those plots show how each feature is distributed. I'm looking for like skew, outliers, and very different scales between variable. And this basically helps decide pre-processing steps like imputation scaling or creating ratio features later. Moving to task 3, we have the function over here. It basically shuffles row indices and returns two data frames, train and test, with the test size equals to test ratio. Next one, it applies the custom function to housing and print the sizes. So here's the sizes. Next function basically shows the first rows of training sets, and it's just confirming the column, and the data looks like the original data sets. That's it. Moving to this function over here, this basically draws histograms for training features, and these distributions help me spot skew and outliers in the training set. Again, it's useful for choosing pre-processing like imputation or engineered ratios. Next function over here, this does the same split but with a fixed seed, so results are repeatable. The next one buckets median income into 5 groups. 1 is the lowest and 5 is the highest. And this function over here, it draws histogram of the new income cat column, and it shows how rows are spread across 5 income bands, and we will preserve this mix in both train and test. Moving to this function over here, it splits the data so train and test have the same income. And now the train test split is satisfied by income, so both sets look similar on this important feature. Moving to the next one, it computes the proportion of each income band in the test set. So those percentage basically should mirror the overall dataset's income distribution, and that's how we know stratification worked. The last function for task 3 is basically remove the temporary income cat column for both sets because it was only used to split. So now moving forward to task 4, this cell creates a safe copy of the stratified training sets, so any edits do not touch the original. Next one, it's a quick latitude or longitude plot. Next function here, same plot with alpha equals 0.1, so dense regions looks darker. The next one, you can see that bigger dots equals to more people. Warmer colors like yellow, red is the higher prices. And you can see high prices near the coast Bay Area and lower prices inland. So population centers tend to be brighter. The next function computes pairwise correlation among numeric features. And this one lists each feature's correlation. And this function shows pairwise plot between key columns. So income versus price has clearest upward trend. this function is basically zoom in on the most important relationship. Higher income is higher house value. And this function creates more meaningful feature by normalizing counts. The last one here, it lists features most related to price. Now, moving forward to task 5. This function, it separates input housing from target housing table. The next one, we have the first option, throws away rows where total bedroom is missing. It's simple but risky, we lose data. The option 2 is remove that feature entirely. So we keep all rows, but we lose this signal. The third option, it replaces missing values with a median of that column. Its best default keeps all rows and it reposts to outliers. This function creates a median imputer, drops the categorical column, and this shows the learned median, so one number per numeric column, and this computes median with pandas. This function returns a number per array with no nonce, so missing values replaced by medians. And this function wraps the transformed array back into a data frame with the original column names. This basically selects the categorical column and show the first 10 values. This function converts categorical categories to integers, and this shows the list of categories. And this function turns the text column ocean proximity into 0 by 1 column. This shows the full 0 by 1 table, housing cat, 1 hot, 2 array. Each row has a 1 for its category. This lists the category names, and this adds 2 to 3 ratio column. This function clean numerics and add ratios and scales. And the last one applies numeric pipeline to numerics and one hot to the category, then combines them. Moving to the last task of the assignment, the first function fits a straight line model on the prepared features. And this function transforms 5 rows with the same pipeline, predicts and prints real labels. This function computes the RMSE equals to average dollar error. So this number is the average error in dollars for linear regression. Lower is better. So yeah, next column fits, next function, sorry, fits a non-linear tree model, can memorize training data basically. And the last function computes the tree training, the RMSE. So if this is very small, even near 0, the tree is memorizing the training set. We must check the CV test later to see real performance. That's all for this assignment. Thank you for watching.